All right, Derek.
All right, well, thank you so much for the opportunity to talk to you all today. So today I'm going to talk to you about primarily the 2023 coral bleaching event on Florida's coral reef. But first, I want to kind of take a step back and put things into a global context and talk about the fourth global coral bleaching event. Next slide, please. So the ocean is heating up, unfortunately, and bleaching events are increasing in frequency and severity. So the first recorded mass coral bleaching event that took place across an entire reef region happened in 1983 in the eastern tropical Pacific Ocean, from Costa Rica to Panama, all the way down to Ecuador and the Galapagos Islands. Now, coral bleaching was known as a stress response before then, but prior to that event, every coral bleaching event had been very, very localized. So the first kind of mass bleaching event occurred in the early 1960s in Jamaica, associated with a hurricane and a bunch of rainfall, dumped a bunch of fresh water into Discovery Bay, Jamaica, bleached the reef completely, but that reef actually recovered in several months' time. So the first mass coral bleaching event that took place due to elevated temperatures over large spatial scale, like I said, was in 1983, and that was associated with a very severe El Nino event at that time. And we've really gone on this trajectory of the ocean continuing to heat up, bleaching events happening all around the world. The initiation of what are called global bleaching events. The first one of those happened in 1998, and I'll talk about that a little bit. But again, the trajectory and where we're going is it's expected that somewhere in the next 20 to 30 years or so, every coral reef on the planet is going to experience heat stress conditions where we're expecting severe annual bleaching. So basically a severe bleaching event every year is the rate that the oceans are warming. And again, there's some variability around that. But in general, by the year 2050, we're anticipating that every coral reef on the planet is going to be having a severe bleaching event every year. Next slide. So the squiggly line there on top shows you global average sea surface temperature from 1985 through the end of 2025, and then that line there on the bottom is the El Nino index. So strong El Ninos are anything higher than a 1.5 degree index. La Nina is the opposite, so that's usually cooler ocean temperatures, and then ENSO neutral kind of describes the intermediate stage. Now, I don't really need to get into the specifics of El Nino and what's driving all that. It's a natural climate fluctuation that causes warmer and cooler ocean temperatures. The issue is, as the ocean gets warmer, the impacts of El Ninos are becoming more severe. So the first global coral bleaching event took place in 1998, which was during the strongest El Nino on record at that time. And then there was a second global coral bleaching event in 2010. And then the third global coral bleaching event took place from 2014 to 2017. And then most recently, the fourth global coral bleaching event started somewhere in 2023. So since 1998, every time we've had a strong El Nino event, there's been a global coral bleaching event. Now, when I say global coral bleaching event, what I'm talking about is simultaneous mass coral bleaching in multiple locations within the three major ocean basins. So Atlantic Ocean, Pacific Ocean, Indian Ocean. And the interesting thing is, the oceans have warmed to the point now where La Nina sea temperatures now are warmer than El Ninos were 3 decades ago. So the global average sea surface temperature from 2019 to 2023 was equal to the values that drove the first global coral bleaching event in 1998. Next slide, please. So this plot is showing you the percentage of reef area on the planet that has experienced bleaching level heat stress over the past 365 days. So The first global coral bleaching event was 1998, and that was associated with about 20% of the reefs on planet Earth experiencing bleaching level heat stress. So when we say bleaching level heat stress, that's based on a metric called a degree heating week. So a degree heating week is simply an anomaly of sea surface temperature greater than the maximum temperature corals normally experience during the warmest part of the year. So Florida, the ocean around the Florida Keys is hottest in August. So a degree heating week simply represents temperatures being a degree Celsius greater than the long-term average temperature in August for a month. So 1 degree heating week would be 1 degree Celsius above that August average temperature for a week, and then 4 degree heating weeks is that temperature for a month. So once you kind of have those month of 1 degree Celsius warmer temperatures, that's when you start seeing bleaching. And then the bleaching response is a time and dose response. So the longer it goes, the worse the bleaching is. That the higher the thermal anomaly is, the worse the bleaching is. So if you have temperatures that are 2 degrees above that average, then you're going to get, to worse case response much quicker. So the take home from this plot is, the percentage of reefs around the planet that are experiencing this bleaching level heat stress is continuing to increase. So each global bleaching event is impacting more and more reefs through time. So this most recent event, it peaked at about 78% of the world's coral reefs were impacted by bleaching level heat stress over the span of 365 days. And the interesting thing is, if you look at the sea surface temperature data, based on the kind of baseline criteria of the first global coral bleaching event, we've actually been under these global coral bleaching sea surface temperature levels since about 2018. So for about the entirety of the last decade, the ocean's been as hot as essentially it was during the first global coral bleaching event. So what this means is bookending these events or defining when they start and when they end are becoming increasingly difficult because, like I said, the first time anyone documented bleaching due to hot water occurring over large spatial scales was 1983. And then, they started seeing that happen in the Atlantic Ocean in the 80s and 90s, to the point now where, any given year, somewhere on planet Earth, there's going to be coral bleaching happening, usually multiple locations. So defining global coral bleaching events is becoming more and more difficult. Next slide. So this is showing you the max degree heating weeks. So as I said in a few slides ago, anything more than 4 degree heating weeks is when we expect bleaching to start. And that's the yellow color in this plot. So anything warmer than the yellow color is likely thermally stressed corals, likely bleaching taking place. So the higher you go on that scale, the worse off you are. So we have various what are called bleaching alert levels at NOAA's Coral Reef Watch. They go from a bleaching alert level 1, which is 4 to 8 degree heating weeks. That's bleaching is expected. When you go 8 to 12 degree heating weeks, that's when we expect mortality to start. And the worst case scenario is a bleaching a level 5. So that's 20 or more degree heating weeks. Now, prior to the 4th global bleaching event, that had only occurred a handful of times, really 3 places, once in the Galapagos Islands in 1983, and then in Kiribati, which is in the equatorial Central Pacific, during the 3rd global coral bleaching event. So if you look at what happened to the reefs during the reefs that experienced more than 20 degree heating weeks, essentially you had coral mortality ranging from about 89 to 98% when corals get hit with that amount of heat exposure. So bleaching alert level 5 is analogous to a category 5 hurricane in terms of it being catastrophic impacts. So anything you see in this plot that is in the tropics where there's coral reefs, where it has that kind of super dark purple black color, that is a place that's experienced more than 20 degree heating weeks in the last 7 years. And again, since February of 2023, there's been confirmed mass bleaching in at least 84 countries and territories. And that number is probably actually 97. So there's about 102 countries and territories that have coral reefs. And the reason I say that's probably 97 is because the 13 countries, we're not getting reports from are places like, Yemen or Iran, places that aren't exactly thrilled with telling Coral Reef Watch that they're experiencing bleaching. So, but it's very likely those places bleached as well, just based on the heat stress. Next slide, please. So this is just showing you heat stress in 2023 to 2025 relative to the entirety of the satellite record. So anywhere you have color on this plot is showing you where we've had record-setting heat stress from 2023 to 2025. So the recent heat stress events have been primarily record-setting in the Atlantic Ocean, both the North and South Atlantic. But there are some patches there in the Pacific Ocean centered around, American Samoa, Southern Great Barrier Reef, also the Red Sea and north of Madagascar. Next slide. So this is just another way of looking at the heat stress distributions through time. And the take home here is, basically the heat exposures are getting more severe and they're impacting more areas. So, during this fourth global bleaching event, 96% of the reef area in the Atlantic Ocean has exceeded 8-degree heating weeks. And again, 8-degree heating weeks is when we expect mortality to start happening in the more heat-sensitive taxa. Next slide, please. So, even before coral started bleaching during this event, the media, the public, everyone wants to know, well, what does this mean? What is this going to mean to the reefs? And the answer to that question is it takes time, right? Because it really takes 1 to 2 years after corals bleach to really know the impacts, because sometimes it's not the bleaching that kills the coral, sometimes it's disease that comes in after the corals bleach because they get immunocompromised. So basically, their immune systems get, affected by the stress of bleaching, and then they get disease after they're starting to recover. But if we look at the previous events, it's estimated about 8% of the world's corals died in 1998, and then there was about a 14% further loss over the second and third global coral bleaching event. So we are now in the process of documenting the impacts of this fourth global event. But we do know, some places saw really bad impacts, like Florida's coral reef, unfortunately. And we already know, what happened there for some of the taxa. And that's what I'm going to get into today. Next slide. So there are actually responses that, various people around the world are doing, because, one of the unfortunate things about a bleaching event is you can't throw ice cubes in the ocean, right? It's not going to have much impact. So a lot of times people feel helpless, or, it's kind of this nihilistic attitude of, well, we can't do anything about it, But there are some things that folks have done. Now in Florida in 2023, temperatures got so hot so fast that coral started dying so rapidly that people started going out and salvaging, essentially trying to salvage the genetic diversity that was still on the reef, right? So going out, taking parts of coral colonies and bringing them to land-based nurseries to basically keep that diversity alive through the event. And other things that were being done is, people were taking corals and moving them into deeper water because the bleaching response is due to an interaction of high temperature and high light. So deeper waters have less light, and sometimes, not always, sometimes they tend to be cooler. So, you could potentially delay and lessen impacts to corals by moving them into deeper water. Another thing you can do is shade corals. But again, these are all very, very limited in scale, right? The Great Barrier Reef's the size of the country of Italy. So you'd be difficult to break out a shade cloth that's going to cover the entirety of Italy. So again, the scale of the remediation that can be done is all, generally very small relative to the impacts. There was about, I want to say, $30 million raised by the UN. Certain countries threw in more money in response to the fourth global bleaching event. In the Maldives, they actually shut down coastal development for a month based on the Coral Reef Watch products. The idea there being that, they wanted to limit any secondary impacts like sedimentation, things like that on corals that are stressed. And then in Thailand, they actually shut down certain tourist areas in hopes that that would reduce secondary impacts on the corals. The idea being less stress, they're more likely to recover and pull through. Next slide, please. So 2023 was a crazy year by pretty much any way you look at it in terms of ocean temperatures in Florida. So not only were heat exposures on average 3 times higher than all years on record in Florida, but bleaching season in Florida is usually August is when temperatures peak. So, when I was back, I lived in Miami for 23 years. So I worked at NOAA in Miami for 20 of those years. And, we used to monitor reefs locally in Florida. And, I like to tell people I wouldn't even start thinking about bleaching until first week of August. I go, okay, what's going to happen this year? And I pull up the temperature record at the Molasses Reef Seaman Station, look at it and go, okay, are we at risk of bleaching this year? Well, in 2023, temperatures shot through the roof in the beginning of July. And so we basically had temperatures hitting bleaching threshold levels 4 to 6 weeks earlier than had ever happened before on record. So we had the magnitude of the heat exposures were 3 times as high, but they also lasted, the heat stress lasted 2 to 3 times as long as well. So that plot there on the left, that's a degree heating week measure. So again, when you get into those purples and blues, that's really bad. You don't want to have that happen, right? Because bleaching generally happens when you get to that yellow, and then the red is when you start seeing mortality. So when you get into purple and blue, that's, category 5 hurricane essentially. And then if you look at the relative heat stress, so 2023 minus the previous maximum amount of heat stress that the Florida Keys had seen, that's that plot there in the middle. So, you could see that the worst of it was really centered around the middle and the lower Florida Keys, where there was 12-degree heating weeks more than had ever been experienced in that location. And then the rest of the Florida's coral reef was essentially, 8-degree heating weeks more than had ever been experienced before. The plot there on the right, hotspots. So hotspots are simply how much hotter the temperature got than the kind of maximum average August temperature, right? So once you get a degree Celsius above that maximum August temperature in Florida, that's your bleaching threshold essentially. So as you can see, we went 2 to 3 degrees Celsius above what happens on average in the month of August in Florida for pretty much the entire region. So take home message here, 2023 was just off the charts. Any way you slice and dice sea surface temperature data, it was record setting in the worst possible way. Next slide, please. So the media took interest in this before any coral bleaching even took place, because certain members of the media are very well educated when it comes to weather patterns, when it comes to ocean processes. In some cases, members of the media are alerting us to things that are happening before we even notice they're happening. But the thing here is that people don't forget now is that we predicted this was going to be really bad, record-settingly bad before any corals bleached, right? So we went out on a limb and we're like, this is going to be horrific, right? And again, that was based on me working for the last 22 years on bleaching in Florida and understanding these thermal thresholds. So yeah, I went out on a limb, but just looking at the temperatures, my first reaction was this can't be actually what's happening, right? Because that's how severe it was. Next slide. So it didn't take long. I think all those press articles started popping up July 11, 12, 13, 14. So by July 20th, we started getting reports in. The Coral Restoration Foundation sent out a press release saying, 100% mortality at Sombrero Reef, which was a restoration site that they had been working on for the last 10 years or so. So again, in a matter of in less than 2 weeks, 10 years of restoration effort was essentially wiped away. So this coral bleaching event got more media coverage than, definitely in the United States, than any other coral bleaching event in history. And that article there on the bottom left, that was on the front page of the Sunday edition of the New York Times. So this was, everywhere in the media. And it was very, very widely reported. And it quickly went from record-setting bleaching in Florida to record-setting bleaching throughout the entirety of the Caribbean. And then by early 2024, it became record-setting global coral bleaching. And these same impacts were being seen in the Indian Ocean, Great Barrier Reef, all throughout the Caribbean, all throughout the Pacific. So this event really took off unbelievably fast. But ground zero, again, was Florida. Next slide. So before we get into impacts, I just want to briefly introduce Acropora. So these are the Staghorn and the Elkhorn corals. And it's really, you can't underestimate or undersell the importance of these two species of coral in the Caribbean. So for at least the past 500,000 years, Elkhorn coral has dominated the reef crests, and Staghorn coral has dominated the mid-slope region of Caribbean coral reefs. So these two corals have been the dominant reef builders for, when I say at least 500,000 years, they first started really becoming dominant reef builders 3 million years ago. So saying 250 to 500,000 years, that's the most conservative estimate you can possibly give, right? So the geologic story in Florida is a little different. The islands of the Florida Keys, those were the barrier reef 125,000 years ago when sea level was higher. So the reef tract today basically started growing about 11,000 years ago, and then developed over the past 10,000 years. Ironically, the main limiting factor to reef growth and coral growth in Florida prior to 40, 50 years ago was cold weather events, right? So cold fronts were the main limiting factor in Florida prior to 40 to 50 years ago. But again, these two species were the dominant reef builders. Pretty much every reef in Florida was built by Elkhorn coral. And if you go jumping in the water off, Fort Lauderdale or something, and that's a fossil reef that stopped growing, 6,000 to 8,000 years ago. But if you swim down to the side of it and look at it, you can see fossil Elkhorn coral was the architect of that reef. So now there's two species of Acropora in the Caribbean. Well, there's actually a hybrid third species, but it's not, it doesn't reproduce sexually. So it's basically a sterile hybrid. So there's really only two species. In the Western Atlantic, now there's over 165 species in the Indo-Pacific, and this is part of the reason why Caribbean reefs, Florida's reefs, one of the multitude of reasons that they really just degraded so severely and so quickly is that there's no functional redundancy, right? So once these two species get knocked down, there's really nothing to move in and replace them. So in the Indian and the Pacific Ocean, you're dealing with 165 species of Acropora. Here we have two. So, these two species are super sensitive to coral disease. Disease is what pretty much wiped them out of the Caribbean and Florida before bleaching became a serious problem. And now disease is essentially, I don't want to say finishing the job, but, it's basically picking up the loose ends, if you will. So Acropora in the Caribbean and Florida has been in peril for at least 40 to 50 years. 80% of the populations were lost from 1980 to 2012. Most of the Acropora were gone in Florida before, long-term monitoring even started in 1996. These are critically endangered species. And again, their architecture supports economically important fisheries. And Elkhorn coral is largely responsible for the shoreline protection that is provided by reefs. So that figure there on the right, that's showing you the long-term monitoring data from Florida Fish and Wildlife. So this was established in 1996, and the image there on the top shows you live coverage of Elkhorn coral, and the one on the bottom is live coverage of Staghorn coral. And you can see, it's just precipitously gone down with these big drops after these known bleaching events. And then, if you look at that, you can see there's very minimal abundance before the 2023 event. Next slide. So these are just some images showing these corals in 2023. So the Staghorn thickets up there on the top, that's from the dry tortugas. So that image there on the left was taken in June 2023. And then, I can't remember the exact date. I want to say that was September 2023 there in the middle. And then again, 100% mortality there on the right. And then the palmata, that's from Key Largo. So the one on the bottom left, that's a pale coral. It's already being thermally stressed and starting to bleach. And then it's fully bleached. And then that bottom right image is from November 2023. It's completely dead and covered in this red turf algae. Next slide. So we got together, pretty much everyone that was tracking Acropora during this event. It's multiple institutions, multiple government agencies, multiple universities, 47 different co-authors. So, and we consolidated all the surveys. So 525 in-water surveys, surveying 391 distinct sites, fate tracking over 50,000 corals. And what we found was 98 to 100% of the Acropora died in the Florida Keys and the dry tortugas. There's really only a handful of colonies that survived in the very upper Florida Keys. Mortality was lower in the Biscayne and the Broward, Miami region because it was cooler farther north. But again, the populations in those regions were much smaller than they were in the Florida Keys. If you squint your eyes and look on those plots, there's the N value, which is the sample size. So you can see in Biscayne, you're starting with about 2,500 corals, and then in Broward, Miami, about 1,750. And the other interesting thing is, I kind of said it earlier, is that, once you go north of Miami, those are all fossil reefs, right? So those haven't grown an inch in the last 7,000, 8,000 years. So those are fossil reefs, right, that were built thousands of years ago. So, one of the ideas is that corals might move north or poleward with ocean warming, and, that is potentially the case. But the take-home message here is, where these Acropora were abundant historically are now essentially all died during this one event. Next slide. So this just shows you a dose response curve. So this shows you the amount of mortality relative to the heat stress. So based on our surveys, palmata was more sensitive than cervicornis. So the Elkhorn was more thermally sensitive than Staghorn coral. And what this is showing you is that, once you get about 8-degree heating weeks, you can anticipate that about 50% of your corals are going to be dead. So if you have a nursery and you're growing these corals and you're tracking thermal stress and you want to know, when do I need to go out and put these corals in deeper water? When do I need to, God forbid, pull them to land in a land-based facility? Well, once you get to about 8-degree heating weeks for Elkhorn, you can expect half your corals to be dead. So cervicornis is a little bit different. It's a little bit stronger. So 11-degree heating weeks. And then when you get to those extreme levels of heat stress, these lines essentially converge. So around 18-degree heating weeks, that's 95% mortality. Then you're talking about just a very, very few of only the very handful of genotypes or genets surviving. So yeah, if interventions need to take place, Elkhorn coral can be justifiably prioritized. It's it's in lower numbers throughout the Caribbean and Florida, and it's also more thermally sensitive. Next slide. So one of the somewhat shocking things that happened was because it got so hot so fast, what happened was we observed rapid mortality and tissue sloughing in a matter of days. So it got so hot that in certain places in the Keys, these corals just died without even bleaching. Their tissue basically just sloughed off. So normally when we talk about bleaching, it's a stress response and corals will bleach. And, it's kind of what happens is because the corals, when they're bleaching, they're expelling all their algal symbionts. So there's zooxanthellae. So the reason that's a big deal is because, this symbiosis, those algae provide about 95% of the nutritional requirements of the coral. So when you expel your zooxanthellae, the corals are essentially starving to death over, a protracted period of several months. Now, when you have these extreme thermal anomalies, it's not really the same bleaching response. It's essentially acute heat shock and just rapid death, right? So this is what happened in places like Sombrero Reef, where they saw 100% mortality in a matter of days. So again, the corals didn't even have an opportunity to bleach. They just dropped dead. So this happened in certain locations on the Great Barrier Reef in 2016 to the most heat-sensitive corals there. And it also occurred in soft corals in Florida, which was very surprising. And the reason I say that is because up until 2023, soft corals were actually one of the taxa in Florida and the Caribbean that had been doing extremely well. So, if you look at long-term records of corals in the Caribbean and Florida, the stony corals, in particular, the Acropora and the mountainous star corals, they've all kind of been declining, whereas soft corals have maintained their populations or even increased their populations. So these are things like the sea fans, the sea whips. So up until 2023, they were much more resistant to warmer ocean temperatures, much more resistant to kind of these disease outbreaks. But what was discovered in 2023 is that they too have a, very clear upper thermal limit by which they just are going to die, right? And just not be able to survive. So in the middle and upper Keys, primarily in the inshore patch reef environments, a lot of the soft corals, unfortunately, died very quickly during this event. So this acute heat shock, again, when we talk about, every coral reef on the planet is going to bleach severely every year, starting in the year 2050, we're talking about kind of that slow burn. We're talking about global ocean warming. And the thing that is really underappreciated is not only are we going to see the baseline ocean temperatures increase, but the extremes are, going to increase as well. And they may, in certain cases, be more severe than kind of that slow increasing burn through time. Next slide. So extinction, when you use the word extinction, there's multiple different types of extinction. So when most people think extinction, I think they think, dodo bird extinction, global extinction in terms of if that species is gone, never coming back, it's history, right? But there's other types of extinction. So there's extirpation, which is local or regional extinction. So extirpation is when a species is displaced and no longer present within a location or region. So great examples that I think we can all understand are things like bison and the gray wolf, right? So these species used to be very widespread across America, and they're not anymore, primarily because of hunting has wiped them out. And driven them to very, very small populations. But they still exist, right? They're not extinct. And then there's functional or ecological extinctions. Now, this just refers to when a species abundance becomes so low that it no longer plays a major role in the ecosystem. So it has direct impacts on community structure and function. So the American chestnut was like a dominant species in forests of North America, but there was a disease that came through and basically wiped it out. You could still find these trees here and there, but they're basically just scattered now and no longer dominant species in America's forests. So that's a functional extinction. Now, these are not mutually exclusive, right? So you can have a functional extinction, also extirpation. So there's a lot of overlap. So when we talk about Elkhorn and Staghorn corals, they were essentially extirpated from the middle keys, the lower keys, and the dry tortugas. Still some colonies in North Key Largo. But they basically went functionally extinct through the entirety of Florida's coral reef. So yes, there are still living colonies in the far north, but they're really not serving a significant role in the ecosystem anymore. And then there's things like commercial extinctions. And this is when when populations become so low or so reduced that it's no longer economically viable to harvest them. So, things like queen conch in the Florida Keys. Way back when it was you could have a job, essentially harvesting conch. And now, it's if you spend any time in the water, yeah, you can see some conch every now and again, but you're not going to make a living harvesting queen conch in the Florida Keys. Next slide. So the 2023 marine heat event, extirpated Acropora from most of the keys and the tortugas, essentially completing the collapse of these two species in the region. Natural recovery is unlikely, and this is for several reasons. One, Florida current in the Gulf Stream runs south to north, right? So where there are survivors, where the Acropora survivors are in the Biscayne, Miami, Broward region, Acropora is a mass spawner. So, a few days after the full moon, the warmest part of the year, they release egg and sperm into the water column, and then they fertilize. And then, if larvae survive and they settle somewhere downstream, well, if these corals are having successful fertilization in the water column, their larvae are not going to, go against the Gulf Stream and travel south to the Florida Keys and seed those sites. And then the other issue, which was already happening before this event, is that these corals were already in such reduced numbers that the odds of successful fertilization were already super low. So in terms of baby corals recruiting on these reefs, recruitment was basically zero to even before this 2023 event. So these corals were not experiencing successful sexual reproduction even before 2023. And then self-fertilization does not yield viable larvae in these species. So this is something that's called the Ali effect. Basically, you could have an Acropora out there that's producing all kinds of gametes, but if there's no one around to party with him, then it's all for naught. He's just it's all just going nowhere, and he's not making any babies. And then the upstream sources where there's Acropora are places like the Yucatan, and the Mexican Caribbean also saw extreme impacts from the 2023 and 24 marine heat wave. They also saw some extirpation events there. So again, this, corals were basically not recruiting to the Florida Keys for this species before 2023. So the odds that you're going to get a larvae that's, made in the Yucatan off Cancun or something, and then it's floating up through the loop current through the Gulf of Mexico, then coming down, around the Tortugas and settling, it's extremely, extremely low. Over geologic timescales, yeah, maybe it'll happen, but in human lifetimes, it's highly unlikely we're going to see any kind of ecologically significant replenishment from these upstream populations. Next slide. So coral extirpation events are on the rise. The first extirpation event was associated with that first mass bleaching event that I mentioned in the Eastern Pacific in 1983. So there were 2 fire corals that were extirpated from the Eastern Pacific. In Florida, Dendrogyra cylindris, which is the pillar coral, was actually extirpated by stony coral tissue loss disease, as well as bleaching. But stony coral tissue loss disease was really the kind of the driver in that relationship. So that happened within the last 5 years. And then one of the species of fire coral in Florida, Melepora complanata, it's the one that makes like the big blades. That actually is very, very rare, essentially non-existent after the 97-98 El Nino bleaching event. So, you know, essentially in the last 20, 30 years, 4 different corals in Florida have basically been extirpated or gone, you know, functionally extinct, which is concerning, right? Because in the Caribbean and the Western Atlantic, it's not like the Indo-Pacific where there's, you know, 700 species of coral. In the entirety of the Caribbean, there's like 65 species of coral. And again, there's only 2 Acropora. And that lack of functional redundancy is one of the reasons the Caribbean, you know, reefs in the Caribbean are kind of in dire straits. And then there's this random species in the Indian Ocean, the Chagos, which is considered the world's most endangered coral. It used to be common, now there's less than 150 colonies. But again, it's really difficult to document extinctions in the ocean because, you know, it's not feasible to document every nook and cranny of every habitable space, right? I mean, you can go out and survey for 10 years and not find a coral and then publish a paper, and then the next day, you know, some fisherman's like, oh, look what I found. And then, you know, so it's really difficult to document extinctions in the ocean. And then traditional survey methods have really limited capacity to monitor rare species. But again, the trend is species, the ranges and the abundances of a lot of species are shrinking rapidly before our very eyes. Next slide. So the only way that we're going to maintain any Acropora populations moving forward is through aggressive interventions. But the catch-22 here is, you know, future restoration that repeats what was done pre-2023 is probably only going to result in the same end result, right? If we done what they did in the past, it's probably just going to have the same end result, unfortunately. So we really need to think outside of the box of what we're doing with restoration and how we're doing it. And we need to be realistic about what restoration success is going to look like. You know, it's going to be limited to very localized areas and ultimately depend on the return time and severity of future bleaching events. We're likely at a point where, you know, gene banking survivors and live biorepositories are probably the only ways to preserve the existing genetic richness of these corals that remain in Florida and the Caribbean. Next slide. So now that everyone's in a good mood, I'll leave on a positive note. So this is the current 4-month bleaching outlook. So Coral Reef Watch is the program I lead, and we produce bleaching alerts in near real time, but we also produce a bleaching outlook that, you know, gives you risk of bleaching over the next 4 months, right? So what you're seeing here is concerning because this is basically showing you a very characteristic El Nino pattern. So when El Nino happens, you get this very, very warm water off the coast of Ecuador, through the Galapagos, through, you know, the equatorial Eastern Pacific. And again, strong El Ninos are basically have been the catalyst of these global coral bleaching events. Next slide. So if we look at what the Coral Reef Watch outlooks look like at the exact same time, before the 3rd global coral bleaching event, before the 4th global coral bleaching event, and then right now, the outlook right now looks far worse than it did right before the 4th global bleaching event and right before the 3rd global bleaching event. And again, based on the sea surface temperature criteria, the 4th global bleaching event hasn't even ended. So again, I don't want to be a fearmonger, but it's looking very likely that we're walking right into a reignition, if you will, of this global coral bleaching event. It's been suggested we may be about to embark on a super El Nino. But again, we don't need a super El Nino. We just need a strong El Nino. And that's basically what has been the catalyst for all these global coral bleaching events in the past. So it doesn't even, like I said, this event hasn't technically even really ended, but we might be looking at global coral bleaching event 5 starting up here in the next couple months. Next slide. So yeah, El Nino, 70% chance of El Nino developing by the end of June. High probability it's going to remain dominant through the rest of 2026. And if we look at, thermal anomalies, this is the hot spot. So these are temperatures above kind of that maximum temperatures that are experienced in a given location. We're seeing the real characteristic El Nino, physical oceanography 101 playing out right now in real time in the Eastern Pacific. So all that hot water around the Galapagos going along the equator, that, again, that is textbook El Nino. So El Nino is starting right now, unfortunately. And if history tells us anything, we're likely looking at a severe bleaching event happening here, starting, around the globe in the next few months to, potentially weeks. Next slide. So global scale coral bleaching has persisted for the nearly, the entirety of the last decade. It looks like it's going to continue again. We're basically in an era now of near annual bleaching for most reefs. So it's difficult, it's increasingly difficult to bound global coral bleaching events, right? Because there's basically bleaching happening all around the world every year now. Whereas it was very different in 1998, where, the first time that happened, it was a very significant event, whereas now it's becoming more commonplace. This El Nino, which potentially could be a super El Nino, is likely going to reignite global bleaching. Hopefully that doesn't happen. Hopefully there's some kind of change in weather patterns. But, looking at all the tea leaves we have in front of us right now, things are looking very worrisome for the next several months. Next slide. So if there's any good news, it's that some of the other massive boulder taxa in Florida had much higher survival following the 2023 bleaching event. Now, again, these were the preliminary kind of surveys that were done. There has been some diseases that have popped up since. So, like I said, it usually takes 1 to 2 years to really know the end impact of a bleaching event. But, the massive and the boulder coral taxa did much better following the 2023 event. But, we still have to keep in mind that temperatures are really nudging towards becoming inhospitable for a lot of different species on coral reefs. So we really are at risk of seeing true global extinctions in the coming decades. And if these extreme heat anomalies become more commonplace, which is likely they are going to, we're likely going to see more of these extirpation events before annual bleaching is realized in the next 20 years or so. And again, bleaching impacts, it's not just corals turning white and dying. Even if corals recover, they can still go on to die due to things like disease outbreaks or coral predators. In 2005, there was a severe bleaching event in the Caribbean, and a lot of the corals in the Virgin Islands survived, but the big killer was, in the year, 1 and 2 years after the corals recovered, they had experienced an outbreak of white plague disease, and that caused 60% decline in coral cover. So it really requires kind of this long-term perspective to see how these heat stress events are impacting the reefs. Next. So I just want to thank the 46 co-authors who made the very depressing Acropora story possible. Again, it was not a fun thing to write, but it's one of those stories that needs to be told. And it couldn't have been done without all these different, people from different agencies and universities and NGOs coming together to share data. And next slide. And finally, I just want to thank the Coral Reef Watch team. that, you know, make me look good on a daily basis. And I'll take any questions if there's time.
Thank you for that presentation. Might have to go talk to a therapist after that one. Yeah, so I will open it up. We just have a small group that's on here to questions. So go ahead and raise your hand and I will get you noticed and be able to ask a question, or you can type your question into the question box if you don't want to ask it aloud. And so Nick, I see you have your hand up. Go ahead, you've been unmuted.
Hey there, can you hear me?
Yeah, I can hear you.
Thanks for the presentation. Yeah, although it was definitely a major bummer, I think it's really important that y'all are doing this work and documenting these, you know, historic events. My question was in regards to if there's any ability for adaptation. I know these events, like on the temporal time scale of how corals grow, it's happening extremely fast, and I know it's probably hard for them to adapt. You mentioned the potentiality of moving northward away from the equator. I don't know, maybe southward from the equator is feasible, and is there any, you know, potential for I guess perpendicular movement? So maybe the corals adapting to less light in deeper water where it's a little cooler, or some of the corals just generally adapting to the warmer waters.
Yeah, so you know, those are kind of the million-dollar questions. So, you know, if you look at the very, very long-term kind of geologic perspective, the scleractinian corals, which are the ones that build reefs today, you know, kind of first evolved 230 million years ago or something. So, you know, scleractinian corals have survived extinction events in the past, right? It's just when extinction events happen, you end up losing a bunch of species, you know, usually a bunch of genera. And one of the interesting things that recent papers showed is that, you know, basically during kind of these extinction events, corals kind of retreat to deeper water or turbid environments, right? So it's basically the corals that are able to adapt their physiology in a manner that, you know, that they can survive in deeper water, less light, or they can survive in turbid environments. And, you know, we're kind of seeing that in the Keys a little bit. Not so much deep water. There's really not much happening in deep water in the Keys, unfortunately. But the turbid, you know, nearshore patch reefs, those are really some of the only places you're going to see considerable corals anymore in Florida. So one of the long-term monitoring sites that I used to manage was at Chica Rocks, and that's, you know, that's basically a refuge for the mountainous star corals. And that site, you know, it went from 30% coral cover to 20% coral cover after this event, which it's a huge decline in coral cover, right? It's like it's like 1/3 of the coral cover died essentially. But, you know, it's considering how hot it got and considering all the soft corals died, you know, it's pretty amazing that there was that amount of survival there. So yes, adaptation is absolutely going to happen. The issue is, you know, survival is not ecosystem function, right? So just because you have corals surviving, they're no longer going to be, you know, growing like weeds and building these giant reefs, right? So the Acropora in the Pacific and the Caribbean, you know, those tend to be the ones that do most of the reef building, and they grow really, really fast, but they're super sensitive. You know, it's just, they drop dead. If you've ever put an Acropora in an aquaria, I mean, you look at them wrong and they just die. So the problem is, yes, corals are probably going to be fine, and we're definitely going to start losing some species, potentially some genera. But in the long term, you know, beyond human life scales, you know, corals will rebound. The problem is, you know, I don't know what the future of the human race is going to look like, but, you know, I think corals are going to be fine. It's just, the question is, what we think of as coral reefs is rapidly going to change. So the ecological functions associated with coral reefs, things like, you know, shoreline protection and things like, you know, fishing, like we like to do, you know, that's going to be impacted. And, you know, corals will adapt. It's just a matter of which ones will adapt, and, you know, how much of those ecological functions are gonna be maintained as this happens. Because again, even if you go back and look at extinction events, unless you're talking about, like, you know, the dinosaur extinction, you know, most of the time the rate of change is not like what we're seeing right now.
Thank you. Thank you.
Yeah, so this is Chip. I was curious on that rapid change that occurred in 2023. You had mentioned there was a 2-degree change in Celsius pretty rapidly, I think in July 2023. Was there something beyond El Nino that was going on that caused that dramatic shift? Or, you know, thinking of like some of the big storm events that we've had that are above water that we've seen. Curious if there was something in the water that caused that rapid shift.
So the 2023 event was very weird. I mean, it was really kind of associated with an atmospheric heat wave, right? So there was really record-setting air temperatures kind of early July. I was actually at Disney World with my family, and it was, you know, it was absurd. I think it was like the hottest July 4th on record or something. So one of the interesting things that happens in Florida, the Florida Keys, is that Florida Bay heats up super fast, right? Because it's really, really shallow. There's really no corals there, but the problem is it's connected to the reefs, right? So all that water, you know, there's a net outflow from Florida Bay to the Middle Keys, to the reefs offshore. And, you know, geologically, those reefs are much poorer developed than they are off Key Largo and the lower Keys. And it's because of that water basically flushing out of Florida Bay. So, you know, basically what happens is when Florida Bay heats up like that, and also because of the, you know, the Everglades, the replumbing of the Everglades, the Florida Bay is now very saline and hypersaline. So you get this very hot, salty water, so that when it moves offshore, it like sinks and, you know, travels along the bottom. So you get that really rapid warming and that really rapid response to atmospheric conditions, right? So, you know, again, you could model that. You could totally model this if you wanted to. It's out of my expertise, but, you know, if you went back 100 years before the Everglades got drained and, you know, replumbed, you know, I'm guessing that type of warming and definitely that type of hypersaline conditions probably wouldn't happen, you know, if you had that natural freshwater sheet flow into Florida Bay. So yeah, 2023 was really, really weird. So that, I mean, that phenomenon was documented, I don't know, 30 years ago or something by Jim Porter. But it seems to be getting worse and worse with time, and that you have this rapid heating of Florida Bay, and then those waters just kind of wash offshore. And then depending on the current patterns, you know, kind of meander around. It can be really detrimental. So yeah, I mean, Florida in 2023 was just really, really weird. You know, I don't want to say it was unexpected, but it kind of was, because, you know, we knew the El Nino was coming. We saw them warming in the Eastern Pacific. We started hearing about bleaching there, which was expected. And then the Florida situation was unexpected. And I don't, you know, I could be wrong, but from my perspective, I don't think it's really well understood why the Atlantic Ocean in particular, as well as the Florida pattern in 2023, and also, you know, the entirety of the Atlantic Ocean, North and South Atlantic, 2023, 2024, and 2025, you know, I don't think it's really well understood why that has just gotten so hot, you know, in the last couple of years. You know, yeah, it's gotten really hot in the Indo-Pacific as well, but it's, you know, it's nothing like what we've been seeing in the Atlantic Ocean. And I honestly don't think that's very well understood.
Yeah, there's a lot of warmer colors that you were showing around the Florida area, which is definitely a little unnerving. And others, please raise your hand if you have some questions. Otherwise, you're going to hear me ask questions. You know, one of the things that we've that has been done recently around the Florida Keys has been to take some coral and move it to deeper water, trying to get it to some cooler areas. You know, there's a lot of challenges with that, right? There's you have to use a human. They have to be diving. They have to go to deeper water, and you know, there's an impact on coral. So I'm wondering, not to say it doesn't need to be done. I realize that has to be done, but I'm just curious about how much coral can be saved using techniques like that, trying to take it from some of the shallow water areas into some of the cooler water refuges.
Yeah, I mean, like you said, I think it depends on manpower. I do know that for some of the species, like Elkhorn coral, so Elkhorn coral is like a super shallow water specialist, right? So it does the best in like extremely shallow water, and it basically, under happy times, you know, it basically outcompetes everything. And it's really the only scleractinian coral that can really grow in that surge and surf zone. So they're really high light specialists. So moving those to deep water, they kind of have a what's the word I'm looking for? There's kind of an expiration date, you know, and how long you can do that. So you can move those to deeper water, but after a certain amount of time, you know, yeah, you might be saving them from bleaching, but they start to suffer physiologically because they just don't do well at deep water. So, I mean, I remember, I think it was 2024, back when Sarah Fangman was still the sanctuary superintendent, because she, you know, she wanted to know, like, yeah, we want to start moving, you know, if it's going to bleach, we want to move corals to deep water, but, you know, we need to know there's only a limited amount of time we can do that before it becomes stressful. So, you know, it comes down to obviously manpower, and then kind of finding the right sweet spot. And then you know, obviously it also, you're banking on the fact that it is going to be sufficiently cooler in deeper water that it's going to, you know, help essentially. But again, like, you know, it all really comes down to scale, really. You know, there's only so many people that can move so much coral, you know, in so much time is really the issue, I think.
Yeah, and not only move it there, but you also have to move it back. It's just, you know, I wish we could do something more to help protect these corals. And another question I had was on your previous slide, where you had mentioned the massive coral taxa exhibited higher survival. It exhibited higher survival, but it still had bleaching, right?
Yeah, absolutely. So yeah, I'm talking about things like what are the common names are like the, you know, the mountainous star corals, star corals. I'm not really good with the common names, so, but yeah, no, they absolutely bleached. And it kind of gets at the question that Nick asked, right? So different species are better able to tolerate certain things. So, you know, some of the corals, so the algae that, you know, are what get expelled when they bleach, there's different species of those algae, right? And there's different, it's been found that there's actually different genera or different genus of these algae, and some are more heat tolerant than others. So, you know, the Elkhorn and the Staghorn, they tend to be very specific with certain species of those symbiotic algae, whereas others corals, like the mountainous star coral, which is also a ESA threatened species, they, you know, they can associate with every species under the sun. So what you see is that when you have a heat stress event, they kind of dump the thermally sensitive algae, and then you'll have like in their tissues, you'll have like repopulation with the more thermally tolerant types of these algae. And some people have, you know, suggested, oh, okay, you know, this is absolutely going to be a survival mechanism. It's a type of evolution. You know, these are corals are evolving, but it's way more complicated than that, because these types of algae that are heat tolerant, they don't seem to be favored unless things are really bad, unless it's really hot. So when temperatures go back down, then over time you see the other algae kind of come back. And then these guys only show up when it gets really hot. But again, moving forward, as kind of heat stress becomes commonplace, happening every year, it's going to be interesting to see how those things kind of play out, because it does seem to be the species that are able to kind of shuffle the different types of algae that are better able to survive. So the massive and the boulder corals tend to be more tolerant in general. When you look at big picture, branching corals versus massive boulder corals. So those are the type of taxa that seem to be more kind of in it for the long run, right? It comes down to all that like ecological theory of like, species that are more stress tolerant, they don't grow as fast, but it's like I can't think of it, it's the tortoise and the hare, right? So it's like, yeah, the hare wins the race, but I guess the hare in this case would be Elkhorn and the Staghorn coral. But yeah, I mean, it comes down to there's all these different little mechanisms. But it is very encouraging that I think a lot of those massive boulder corals did a lot better than I think a lot of people would have thought in 2023.
Thank you for that response. Any other questions? If not, I will give Derek back the rest of his day. All right, not seeing any hands go up. Derek, thank you so much for the presentation today. I know it's a hard topic to talk about, but I think it's really informative. And coral is an extremely important species in the South Atlantic, not only because it's a managed group of species, but also because it is essential fish habitat for so many species that we try to manage here in the South Atlantic. So thank you for taking your time out and giving us a highlight of what's been going on with coral over the past really decade and further back. So thank you.
Yep, my pleasure. Appreciate it.
Everybody have a good afternoon. We're not gonna have a seminar series next month due to the council meeting, but we'll have one coming up in July. So thank you all for your time today.